Howdy everyone, this is Dylan again, and now I will be introducing you guys to the Planet Designer activity. So the gist of the activity is, well, you get to build your own planet. So that entails basically picking the radius, the surface composition, the atmospheric density, and a slew of other properties to kind of see how they culminate in your very own planet. So when you first enter the Planet Designer tool, you will see exactly what we're seeing right now. You will see a fairly generic looking planet. On the right, you will have this top bar up here on the top with a bunch of buttons, and you will have this area on the left side that says Getting Started, and then a description of what everything does. So here on the right, if you right click, you can rotate and get different views of your planet, which will be important when it's doing different things later. At the top bar, we have a bunch of things that can help you out, such as naming the planet, giving the planet a description, creating this clicking this Create New Planet button, which will basically start over. We also have these planetary presets, which will allow you to start your planet with all of Mercury's parameters, or Venus's, Earth, or Mars. So let's just click on Mars. And so this is a planet which, if we click through, has all of Mars's properties decided. I'm going to quickly flip through these pages, which will go in a lot more detail later. So there's one more button on this page, and that is the Random Parameters button, which will basically create an entirely random planet for you to either use or just start off with. Continuing down the top bar, next button is the Save Planet button, which allows you to save your planet. The Load Planet button, which allows you to load this camera, which we will get back to later. It is the screenshot mode. And then go to Main Menu and Exit Simulation. So these top buttons up here are not how you actually change your planet. They're obviously, there's a lot more things that go on than just these top buttons. So let's get into those. So if you look over here on the left, this is the main area where you will be affecting your planet. We have 6 tabs. We have a globe, which is our general properties, a mountain range, which is our surface properties, a breeze, which is our atmospheric properties, this binoculars, which will show you different planetary lenses, this airplane patch, which will allow you to visit your planet, and then this question mark, which will bring you back to this description of everything, all the buttons that we have. So let's just jump straight into the general properties page. So if you click this globe, we get the planetary properties. So we talked about most of these in the lesson, and so we can briefly kind of glimpse over them, with the radius making the planet bigger or smaller. The mass actually makes the planet a lot more compact and brings in all of the matter within it. The orbit distance pushes it away from the sun, making it receive a lot less sunlight and drastically affecting the temperature of the planet. If you look down here, let's bring that back a little bit. Yeah, 30 seems about, no, that's way too warm. That's got to be good enough. The age of the planet, which will affect, the age of the planet is the next one on the list, and this will affect the how weathered the planet looks. The tilt angle of the planet is the next one, and this is the tilt axis, so the axis at which the planet will rotate at. And let's kick up the rotation speed so you can really see how this tilt angle works. So this is right now at 0 tilt angle. The Earth would be around here-ish, rotating like this. And then Uranus was around 90, a little bit less than 90, or a little bit over 90, sorry. And it's basically a rolling ball through its orbit. And then Venus was actually at 177. So what's interesting is it's basically just rotating backwards. So if you have 177 degrees and then go, you can very clearly see that They're just rotating separately. So that's tilt angle and rotation speed. They kind of work hand in hand. The last one on the list, albedo, is the one I would expect you maybe not to know. So the albedo is the reflectivity of the planet. It is how much light that hits the planet is reflected back into space. So this has a drastic effect on the temperature, because if you're reflecting more sunlight, the temperature of the planet will be cooler, and you can actually see that. If we increase the albedo a little bit, the temperature goes down. So the albedo of planets is it's in a closer range. So albedos of planets don't really get too high. So the albedo of Venus is around 0.7, and the albedo of the Earth is around 0.3. They don't get very close to 0 or very close to 1. They're normally around the midway mark. The last thing isn't a property at all, but if you say you like all of the properties for your planets, you just don't like how it looks, or you want to generate another planet that looks that has the exact same properties, you can change the seed, which let's just say 1, 2, 3, which will generate an entirely different planet with the same properties. So those are all of the main planetary properties. If you have any questions or are confused about any of them, we have these information buttons. So let's say we want to learn more about the radius of planets. It'll give you a description, and then it'll actually tell you the radius of all of the planets in our solar system to kind of give you a gauge. And it's the same for all of these. So let's go back to albedo, because that's probably the most confusing one. If you ever forget what albedo is, we can this will give you a little brief description. So now let's move on to the next tab. The next tab is the surface properties tab. And so this tab is split into two parts. We have the surface composition up here, and we have oceans down here, which we will get to in a bit. So the surface composition works like you would think it would, where you can basically determine how much of each of these elements you want along the surface of your planet. And be aware that the iron is pretty heavy. So a lot of iron in the surface tends to, or a high percentage of iron, I guess I should say, tends to be very evident, which is why, because Mars has a lot of iron compared to Earth, but Mars doesn't have more than 15% iron on its surface, and yet it is very, very red. So one rule of thumb, you don't have to abide by this at all, but it is just kind of a little fact, that all of the planets within our solar system, at least all of the inner ones, all of the terrestrial planets, are around 2/3 oxygen and silicon. So if you keep these around 2/3, you will get at least more accurate planets, and most likely more good-looking ones. But having said that, make whatever composition you want. It's all up to you. So the next thing on this page is the oceans. So the oceans allow you to, they basically take the temperature of the planet, and they distribute whatever composition you pick, whether it's H2O, methane, sulfur, or nitrogen, into its 3 states of matter. So the freezing point of water is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius. So since we put the temperature of the planet right now at around 10 degrees Celsius, we're going to have a little bit of ice caps, because certain areas of the planet will be colder, and then we'll mostly have some strong bodies of water. So what this basically does is, as we add a volume, it splits that volume amongst the 3 states of matter. So some will be in a solid state along the poles. Oh, let me move the tilt angle back so you can see it on both poles. So this is ice along both of the poles of the planet, and then the rest is liquid water. And there's actually a little bit of water in the atmosphere, but you can't see that right yet. So if we actually change the temperature of the planet, we will see this affect how much ocean, how much ice caps, how much liquid we have in, how much liquid water we have in the, not liquid water, but gaseous water we have in the atmosphere in real time. So let's do that. Let's just pull it super far away from the sun. basically all the oceans accumulate at the poles. So we just have ice caps. But if we bring it in super close, eventually the ice caps melt, we have oceans, and eventually the oceans evaporate up into the atmosphere. So let's leave a little bit of ice caps because I quite like this. So that is the oceans, but there are 4 other types of oceans. So there's methane, sulfur, nitrogen, like I said before, and each of them have different freezing points and boiling points. So they will drastically affect where you can get liquid oceans or ice caps, very much depending on which of these 4 you pick. So the last page, which lets you affect the planet in a meaningful way, is the atmospheric composition page. So this works very similarly to the surface composition, but it's the atmosphere. So the atmosphere of the Earth is around 80% nitrogen, around 20% oxygen, and like 1% argon, and a smidge of carbon dioxide, methane, and hydrogen. But like so much so that it wouldn't even matter. So one thing to note is that although I have described my atmospheric composition here, you cannot see anything over here because the density is 0 and the scale height is 0. So as soon as I up that density to, let's say there, and give it a scale height, we have a nice looking atmosphere around our planet. So what's something that's really cool is that the density and the scale height of the atmosphere both directly affect the greenhouse effect. So as our atmosphere is bigger, as it is thicker, the temperature of the planet increases, which will have the effects on the ocean that we just described. So if we actually up this density to something crazy, the polar ice caps just melted, and then all the water just evaporated into the atmosphere, and we just basically have what we saw before with a very hot temperature. And this is a very extreme density. So the density of Venus's atmosphere is around 65, which is still very extreme because the density of Earth's atmosphere, 65 kilograms per meter cubed, and the density of Earth's atmosphere is all the way at around 1.2 kilograms per meter cubed. So it's a very weak atmosphere compared to Venus, but very strong compared to Mars, because Mars's atmosphere is all the way here. So barely an atmosphere at all. And then of course Mercury and the Moon's atmosphere are 0. But let's change our composition a little bit. Let's add a lot more argon. And as you change the composition, you affect the color of the atmosphere, because different molecules reflect different wavelengths and absorb different wavelengths of light. So you can really create cool looking alien atmospheres with this. Yeah, let's go with that. So these first 3 tabs are the main ways that you edit your planet. The last 2 are how you view it. So if we click here, we have our planetary views, and they're just 3 buttons up ahead. So we have the surface view, which is how we've been viewing it this entire time. It's just the surface of the planet. We have the topology view, which will use this topology legend down here. So if we click that, you will see where different terrain types are, so where there are mountains or deserts or salt flats or oceans. And then if we click the height view, this will give us an altimetry scan of the planet, where the blues are the low points and these bright greens are the high points. And of course you can edit your planet in these modes. So let's say I just want to down the radius. You can see editing the radius affects the height and all that stuff. Where was Oh yeah. So let's go back to the surface view. I must have drastically affected my planet. It's a lot smaller now. So before we get into the visit your planet mode, let's talk about the screenshot mode, which is arguably just as cool. So let me up my planet a little bit more. Let's give it a slightly different tilt angle. Let's make it rotate a little bit quicker. And let's go click up here to hide the UI and enter screenshot mode. So this will generate your planet at a much higher detail than what we're seeing right now, and it will allow you to take much cooler screenshots. So let's click ultra detail. And so this is my planet. It actually looks pretty cool. That lake looks like Australia. Oh my goodness. You'll see all types of images in the lakes and the oceans you make. It's kind of like cloud watching. But yeah, so this is how you see your planet. You can take screenshots of it, and we definitely encourage you to take screenshots of your beautiful planets. So let's go back to the builder mode and jump straight into the embark mode. So this is the last thing with our planet builder, and that's the embark mode. So the first thing that happens is we have this green little dot on the planet, and this is where you will be embarking to. So you can change the longitude and the latitude of this dot to move where it is along the surface of the planet. So let's just say we want to embark right there, right here. And if say you want to embark on the other side, you can move the sun around in its orbit and embark to wherever you want. So all you have to do is pick a landing site and click the embark button. Oh, and pick a simulation. Here we go. So it'll load you into the sim. It'll generate the terrain. You can pick any astronaut you want. Might as well. Let's pick astronaut 2. And you can explore your planet. So this will allow you to, if you get really close to the surface, get a sense of how big these planets are. So let's, this is 4 meters per second, which is actually, that's pretty fast. This would be closer to, yeah, this would be still a brisk walk. This is about walking speed along the surface. I guess we're going uphill, so it makes sense that it's a little bit slower. But you can go much faster and kind of just explore the planet that you made, or go way off into space. So yeah, I'm very much looking forward to seeing all the planets that everyone builds and the cool stuff that they create, and seeing screenshots of all the explorations and of all the planets. Thank you so much for taking the time to watch this video, and yeah, thanks and gig 'em. See ya.